Hello everyone, welcome to the lecture again. In the last lecture, we solved one example wherein we find out the inertia matrix and principal moment of inertia of an assembly made of thin plates. Today, we are going to continue the discussion on the same concept and we will find out the inertia matrix, the principal moment of inertia and principal axis of inertia of another assembly. So, the problem statement is following. The angle bracket is made from aluminum plate with a mass of 13.45 kg per square meter. Calculate the principal moment of inertia about the origin O and the direction cosine of the principal axis of inertia. It is given that the thickness of the plate is small compared with the other dimensions. So, this angle bracket can be divided into three parts. So, here this is x axis, the y axis and the z axis. Let us say this is part 1, okay, the entire plate on the x z plane. Then part 2 is that circular plate, okay, and part 3 will be the another plate on the y x plane. So, that is this. So, this is part 1, part 2 and part 3. The entire assembly can be think of part 1 minus part 2 plus part 3. Okay. So, let me put the dimensions. So, let us say this is A, this is B. So, therefore, let us say this dotted line, it passes through the center of mass of this plate, then that length will be B by 2 and this will be A by 2. Okay. Now, the value of A and B is of course known to us. Now, let us look at the second part. So, this part. So, again this dotted line passes through the center of this circle. It is given that the diameter of this is 70, okay, and it is situated at a distance of 50 mm. Okay, and this length is 160. Now, for the third part, this length is 120 and this is 110. Now, we have to find out the principal moment of inertia of this bracket. For that, we need to know the moment of inertia and product of inertia of all these three parts. For that, let us first look at the mass of the three part. Okay. So, for the first part, let us say the mass is m1. So, that will be density multiplied by the area. Okay. So, density is 13.45 into the length. So, A is 210 mm and B is 100 mm. Okay. So, that will be equal to 0.21 into 0.1 and that will be 0.282 kg. The mass of the second part m2 which is removed will be equal to the density multiplied by the area. So, pi into r square 0.035 square and that will be equal to 0.0518 kg. Mass of the third part will be the density multiplied by the area. So, 0.12 into 0.11 and that is equal to 0.1775 kg. Okay. So, now we know the mass of all the three part. Let us calculate the moment of inertia and product of inertia of part 1 first. Okay. So, part 1, the moment of inertia about the x axis Ixx will be equal to the moment of inertia about this axis plus the m b by 2 whole square. So, we can use the parallel axis theorem. The moment of inertia about this dash axis will be m b square divided by 12 plus m b by 2 square. Okay. So, herein we have used the parallel axis theorem. Okay. So, this is equal to m b square divided by 3. Now, the value of m is known, value of b is 100 mm. So, therefore, this comes out to be 9.42 into 10 to the power minus 4 kg meter square. Now, the moment of inertia about the y axis we can calculate by using the perpendicular axis theorem, because this plate lies in the x z plane. So, therefore, let us first calculate the moment of inertia about the z axis. Okay. The moment of inertia about the z axis can be calculated using the parallel axis theorem. So, for that let us first calculate the moment of inertia about the dashed red line and then use the parallel axis theorem. So, it will be m into a square divided by 12 plus m a by 2 square, okay, and that is equal to m a square divided by 3. Now, again the value of m and a is known. So, therefore, it comes out to be 41.5 into 10 to the power minus 4 kg meter square. Again we have used the parallel axis theorem. Okay. Now, Iyy will be Ixx plus Izz. So, that is equal to m into a square divided by 3 plus b square divided by 3 and that is equal to this plus that. So, it comes out to be 50.9 into 10 to the power minus 4 kg meter square. Now, note that the thickness of the plate is very small. So, this thickness that you see here is very small. Therefore, y will be 0 in terms of thickness. So, the product of inertia Ixy will be m into x into y, but then y is small. So, therefore, that comes out to be 0. Similarly, Iyz will also be 0. Okay. Now, let us find out Ixz. So, for the Ixz you can use the parallel axis theorem. We can first find out the moment of inertia about these axes. Let me call them Ixz bar plus m into A by 2 into B by 2. Okay, so this comes from the parallel axis theorem. Okay. Now, the I bar xz will be 0 because the plate is symmetrical about this axis. So, let me mention this clearly. The product of inertia will be 0 for symmetrical object when a coordinate axis is also an axis of symmetry. Okay. So, you can see here that the green axis, which is the axis of symmetry, therefore, the product of inertia about it will be 0 plus m a by 2 b by 2. Okay. And the value of a, b and m is known. So, that comes out to be 14.83 into 10 to the power minus 4 kg meter square. Now, let us look at part 2. So, the part 2 was the ring. Okay. So, it was given that this is 50, this is 160 and the radius is 35. So, the diameter is 70. Okay. So, this was our part 2. So, for part 2 the everything will be negative because this part has been removed. So, let us look at the moment of inertia about the x axis minus of that will be minus. Again we can use the parallel axis theorem. So, we can first calculate the moment of inertia about this line and then we can use the parallel axis theorem. So, that will be m r square divided by 4 plus m into 50 square. Okay. So, r is also known, m is also known. So, that comes out to be minus 1.453 into 10 to the power minus 4 kg meter square. Okay. Now, the moment of inertia about the z axis izz can be calculated if we find out the moment of inertia about this axis and then use the parallel axis theorem. So, that will be minus m r square divided by 4 plus m into 160 square, okay. And that comes out to be minus 13.41 into 10 to the power minus 4 kg meter square. Now, since this plate lies in the xz plane, therefore, the moment of inertia about the y axis will be the sum of the moment of inertia about the x and the z axis. So, let me just write down that will be minus I xx plus I zz and that is equal to minus 14.86 into 10 to the power minus 4 kg meter square. Now, let us look at the product of inertia. So, the product of inertia I x y, that will be equal to 0 because the plate is thin. So, thin plate, therefore, y can be taken as 0. So, I x y will be m into x into y, but y is 0, therefore, I x y will be 0 and also I y z. Now, I x z can be find out by using the parallel axis theorem. For that, we should know the product of inertia about the axis marked by the red and let us say it is equal to I x z bar plus m into 0.16 into 0.05. Okay, so minus, that will be minus. Now I bar xz will be equal to 0 because this disk is symmetrical about the axis marked by the red. So therefore this is equal to 0. Then we have minus m is known here. So that comes out to be 4.14 into 10 to the power minus 4 kg meter square. Now let us look at part 3. So part 3 is lying in the xy plane. So that is our part 3, and this is 120 mm, so 0.12 meter, and this one is 0.11. Okay. Let me call this is equal to D and this is equal to C. Okay. So the moment of inertia about the x axis will be equal to the moment of inertia about this axis plus m into d by 2 square. So that is equal to m d square divided by 12 plus m d by 2 whole square. Again we have used the parallel axis theorem, and that comes out to be 1 by 3 m d square. Now the value of m and d is known, so that comes out to be 8.52 into 10 to the power minus 4 kg meter square. Now the moment of inertia about the y axis will be m c square divided by 12 plus m c by 2 whole square, and that is equal to 1 by 3 m c square, and that is equal to 7.16 into 10 to the power minus 4 kg meter square. Now the moment of inertia about the z axis can be found out using the perpendicular axis theorem. So that will be equal to I x x plus I y y, that is equal to 1 by 3 m d square plus 1 by 3 m c square, and that is equal to 15.86 into 10 to the power minus 4 kg meter square. Now let us find out the product of inertia. Since the thickness of this plate is very small, okay, so therefore z will be 0. So since thickness is small, so therefore this time z will be equal to 0. Therefore I y z, which is equal to m into y into z, that will be equal to 0, and so is I x z. Okay. Now I x y can be found out using the parallel axis theorem. So let us say the product of inertia about this is I bar x y, then I x y will be equal to I bar x y plus m into c by 2 into d by 2. Okay. Now I bar x y will be equal to 0 because this structure is symmetric about the the new x y which is marked by the green axis. So that is equal to 0 plus m is known, and c by 2. Note that d will be minus d here because this is your positive y. Okay, the direction of positive y is opposite to the d, so therefore minus d by 2. Now the value of m, c and d is known to us, therefore this comes out to be 5.86 into 10 to the power minus 4 kg meter square. So we have find out the moment of inertia and product of inertia of all three parts. Now let us write down the total moment of inertia. Okay. So total moment of inertia, let us say I x x. So I x x will be equal to the moment of inertia of the first part about the x axis, that is 9.42 into 10 to the power minus 4. So, 9.42 into 10 to the power minus 4 minus the second part. So, that is equal to 1.453 into 10 to the power minus 4 plus the moment of inertia about the x axis of the third part, that is 8.52 into 10 to the power minus 4. Okay. And this comes out to be 16.48 into 10 to the power minus 4 kg meter square. Similarly, Iyy comes out to be 43.2 into 10 to the power minus 4 and Izz comes out to be 43.8 into 10 to the power minus 4 kg meter square. And the product of inertia Ixy comes out to be 5.86 into 10 to the power minus 4 and Iyz, let us look at Iyz. So, Iyz, here it was 0 plus, for the second part it was also 0 and for the third part also it was 0, equal to 0, and similarly Ixz equal to 10.69 into 10 to the power minus 4 kg meter square. So, we have the moment of inertia and product of inertia of all the parts. Now, to calculate the principal moment of inertia, we have to use the following equation: Ixx minus I minus Ixy minus Ixz minus Iyx Iyy minus I minus Iyz minus Izx minus Izy and Izz minus I equal to 0. Okay. Let us put the values. So, we have 16.48 into 10 to the power minus 4 minus I, then we have plus 5.86 into 10 to the power minus 4, then we have minus 10.69 into 10 to the power minus 4, 5.86 into 10 to the power minus 4, 43.2 into 10 to the power minus 4 minus I, and this was 0, then minus 10.69 into 10 to the power minus 4, 0, and 43.8 into 10 to the power minus 4 minus I equal to 0. Now, this equation we can solve by expanding this. So, that will be 16.48 into 10 to the power minus 4 minus I multiplied by 43.2 into 10 to the power minus 4 minus I into 43.8 into 10 to the power minus 4 minus I minus 5.86 into 10 to the power minus 4, 5.86 into 10 to the power minus 4 and 43.8 into 10 to the power minus 4 minus I minus 10.69 into 10 to the power minus 4 into 10.69 into 10 to the power minus 4 into 43.2 into 10 to the power minus 4 minus I equal to 0. So, this equation I can simplify. After simplification, we get I to the power 3 minus 103.5 into 10 to the power minus 4 I square plus 3180 into 10 to the power minus 8 I minus 24800 into 10 to the power minus 12 equal to 0. Now, this equation is in the form of I to the power 3, therefore, it will have 3 solution of the i's, and let me write down the solution. So, I1 is 48.3 into 10 to the power minus 4 kg meter square, I2 will be 11.82 into 10 to the power minus 4 kg meter square, and I3 comes out to be 43.4 into 10 to the power minus 4 kg meter square. These are your principal moment of inertia. Okay. Now, let us find out the principal inertia axis. Corresponding to I1, I2, I3, and for that we can use the equation Ixx minus II, here small I corresponding to 1, 2 and 3, L minus Ixym minus Ixzn equal to 0 minus Ixyl plus Iyy minus II into m minus Iyzn equal to 0 minus Izxl plus Izym plus Izz minus Ii into n equal to 0, and we also have L square plus m square plus n square equal to 1. Now, for Ii equal to I1, which is equal to 48.3 into 10 to the power minus 4 kg meter square, I can solve these equations and I get L1 equal to 0.357, M1 equal to 0.410 and N1 equal to 0.839. So, you can check that L square plus M square plus N square, that will be equal to 1 here. Similarly, for II equal to I2 equal to 11.82 into 10 to the power minus 4, you can find out again the L, M and N. So, here L2 comes out to be 0.934, M2 comes out to be minus 0.1742 and N2 comes out to be 0.312. And similarly, for II equal to I3, that is equal to 43.4 into 10 to the power minus 4 kg meter square, L3 comes out to be 0.0183, M3 comes out to be 0.895 and N3 comes out to be 0.445. So, these are the direction cosines of the principal inertia axis. Now, let me show you the orientation of principal axis of inertia. Corresponding to L1, M1 and N1, we have the first principal axis. Corresponding to L2, M2 and N2, we have the second principal axis, and corresponding to L3, M3 and N3, we have the third principal axis. If we calculate the product of inertia of this structure about 1, 2 and 3, then it will be the 0. There will not be any product of inertia. Now, this has the implication when we study the angular momentum and rotation of the rigid bodies. With this, let me stop here. See you in the next class. Thank you.